Hello everyone. Today we have to learn about partial fractions. Before that, we must know some mathematical definitions regarding polynomial. Means like degree of polynomial, linear polynomial, quadratic polynomial, cubic polynomial, like this. Means we must find degree of given polynomial. Next part is we must know about rational function, proper rational function, and improper rational function. Okay, as well as we must know reducible quadratic factor and irreducible quadratic factors. Let us study about some polynomials. This is x. This is a polynomial. Power of x is 1. So degree of this polynomial is 1. Ax. Here also a is constant coefficient of x. Power of x is 1. So degree of this polynomial is also 1. Let us consider ax plus b. Ax plus b we can express like this: ax plus b into x to the power 0. You know x to the power 0 is 1. So b into 1, that is b, like this. So ax plus b is equal to, we can write ax plus b into x to the power 0. And here also there are two terms. This term power of x is 1. So degree of this term is 1 and degree of this term is 0. Okay. So 0 is less than 1. Highest power of x is appearing in this term. So degree of this polynomial is 1. Okay. And you know polynomial of degree 1 is known as linear polynomial. So here degree is 1 and this polynomial is known as linear polynomial. Okay. Now we have to consider next example. X square, power of x is 2. Then a into x square, here also power of x is 2. This is single term, this is also single term. Let us consider this: ax square plus bx plus c. There are three terms. Here degree of this term is 0. You can write this as into x to the power 0. Degree of this term is 1 and degree of this term is 2. So highest power of x, it is appearing here in first term. Okay. Remember, highest power of x, that is nothing but degree of that term as well as degree of that polynomial. So degree of this term is 2 and degree of this whole polynomial is also 2. Okay. And now if you consider this example ax square plus c. Here degree of this term is 2 and degree of this term is 0 because this is constant. So here in this case degree of polynomial is 2. Such type of polynomial is known as quadratic polynomial. Degree of this term is 2, which is highest power of x in first term. So degree of this term is equal to degree of this whole polynomial, and which is 2. Let us assume another example, this one. Here x cube, power of x is 3. Here a into x cube, power of x is also 3. Both are single term functions. And here there are 4 terms. Degree of this term is 3. Degree of this term is 2. Degree of this term is 1. And degree of this term is 0. But highest power of x is appearing in first term. So degree of this term is equal to degree of this polynomial, and which is equal to 3. Here two terms are there, ax cube plus d. Degree of this term is 3 and degree of this term is 0. So degree of this polynomial is 3. Degree of this polynomial is also 3 and degree of this polynomial is also 3. So here we can say degree of given polynomial is equal to 3, and such polynomials are known as cubic polynomial. Okay. Now another example is like this: ax to the power 0 plus bx plus cx square plus and so on k into x to the power n, suppose. Okay. And here power of x is 0. So degree of this term is 0. Degree of this term is 1 because power of x is 1. Degree of this term is 2 and degree of last term, which is n. Okay, n is suppose greater than all numbers starting from 0, 1, 2 up to n minus 1. Then this n will be highest power of x, and degree of this term is n, as well as degree of this whole polynomial is also n. So degree is equal to n. Hence we can define degree of a polynomial like degree of a polynomial is degree of the term containing highest power of x. Now let us know about new concept, that is rational function. Function f of x, which is expressed in the form of p of x upon q of x. This is known as rational function, where p of x and q of x both polynomial functions. Okay, such type of function is known as a rational function. Now let us know about proper rational function. Here in rational function, if suppose degree of numerator is less than degree of denominator, means degree of px is less than degree of q of x, then that rational function is known as proper rational function. So we can write here degree of numerator is p of x strictly less than degree of denominator is q of x. Then such function is known as proper rational function. Okay, let us know about improper rational function. Rational function in which degree of numerator, that is p of x, is either greater than or equal to degree of denominator, that is q of x, then that type of rational function is known as improper rational function. Degree of p of x is either greater than or equal to degree of q of x. This is improper rational function. Let us know about reducible quadratic factors. Reducible quadratic factor means quadratic factor whose linear factors can be obtained. Meaning of this is very simple. Quadratic factor which is reducible to linear factors, then that quadratic factor is known as reducible quadratic factor. Let us know about irreducible quadratic factor. Quadratic factor whose linear factors cannot be obtained. Meaning of this is what? Quadratic factor which is not reducible to linear factors, that quadratic factor is known as irreducible quadratic factor. Now we have to learn about types of partial fractions. There are total 4 types of partial fractions. Type number 1, when denominator, this dr is nothing but denominator. When denominator contains non-repeated linear factors. Denominator, its factors we obtained and all are linear factors and no one factor is repeated. So in this case we are assuming proper rational function which is given by p of x upon q of x. Okay, and here denominator q of x, its linear factors are non-repeated. Suppose this rational function is given by, we are assuming only denominator. All these types are depending upon factors of denominator. Okay, means nature of denominator. Numerator as it is, suppose denominator qx, its linear factors are a1x plus b1. This is first linear factor. Second one is suppose a2x plus b2. Third one is suppose a3x plus b3. These three factors are there suppose, and no one factor is repeated. Then first of all you have to express right hand side in this form. This is equal to arbitrary constant a divided by first linear factor, that is a1x plus b1, plus arbitrary constant b divided by second linear factor, that is a2x plus b2, plus arbitrary constant c divided by third linear factor a3x plus b3. Like this, there may be two linear factors or maybe more than two linear factors. In all cases, you have to express like this: arbitrary constant a upon first linear factor plus arbitrary constant b upon second linear factor plus arbitrary constant c upon third linear factor. This is regarding type number 1. Type number 2 is when denominator contains repeated linear factors. Now we are assuming rational function in which denominator contains repeated linear factors. Let f of x is equal to p of x upon q of x, and it is suppose like this: p of x divided by a1x plus b1, this is linear factor, a2x plus b2, this is also linear factor, and suppose a3x plus b3, this is repeated for 3 times. Suppose cube of a3x plus b3, meaning of this is a3x plus b3, this linear polynomial is repeated for 3 times, but a1x plus b1 and a2x plus b2, these two linear factors are not repeated. Means for non-repeated linear factors you have to apply type number 1. This is equal to arbitrary constant a divided by first linear factor a1x plus b1 plus arbitrary constant b divided by second linear factor, that is a2x plus b2 plus c upon third linear factor is repeated for 3 times. So first of all its first power a3x plus b3 plus d upon, now increase power by 1, a3x plus b3 square of this plus up to cube e upon a3x plus b3 its cube. Okay, like this you have to express this linear polynomial in this form, and then you can find its partial fractions. But this representation of given rational function is very important to get the partial fractions of given rational function. Type number 3 is when denominator contains non-repeated irreducible quadratic factors. Let us assume rational function like this: f of x is equal to p of x upon q of x, and numerator p of x is as it is. We are obtaining factors of denominator, and that denominator is suppose containing such type of factors: a1x plus b1, a2x plus b2 its square suppose into a3x square plus b3x plus c3. Here we are assuming this is linear factor non-repeated. This linear factor is repeated for 2 times. For this linear factor you have to apply type number 1. For this repeated linear factor you have to apply type number 2. And this is quadratic factor but which is irreducible, means its linear factors we can't find. So for this you have to apply type number 3. So we can write this as this is equal to a upon a1x plus b1 plus b upon a1x plus b1 is linear factor, and this linear factor is repeated for 2 times. So first power a2x plus b2 plus c upon a2x plus b2 square of this, and now this quadratic factor. For this quadratic factor, remember, when denominator is linear factor, then numerator will be arbitrary constant. But when denominator is quadratic factor, then numerator must be linear factor. So a, b, c. Next arbitrary constant dx plus e. Because denominator is quadratic, numerator will be linear polynomial a3x square plus b3x plus c3. Okay, you have to express f of x in this form: a upon linear factor plus arbitrary constant b upon second linear factor its first power plus c upon second linear factor its power 2 plus here third factor is quadratic, so numerator must be linear polynomial, so dx plus e divided by a3x square plus b3x plus c3. In this way we have to express given polynomial and then we can find its partial fractions. Type number 4 is when denominator contains repeated irreducible quadratic factors. We are considering polynomial f of x is equal to, suppose, p of x upon q of x, and this polynomial is given like this: finding factors of denominator. Okay, suppose one factor is linear, a1x plus b1. Second factor is quadratic, suppose second factor is a2x square plus b2x plus c2, and this is non-repeated, suppose, and third factor is also quadratic, which is irreducible quadratic, a3x square plus b3x plus c3, and suppose this is repeated for 2 times. Linear factor, this is quadratic non-repeated, means for linear factor you have to apply type number 1. For quadratic factor which is non-repeated you have to apply case number 3 or type number 3. And for quadratic factor which is irreducible and repeated for 2 times you have to apply case number 4. So you have to express this in this form: arbitrary constant a divided by linear factor a1x plus b1 plus, this is quadratic factor, means denominator is quadratic factor, a2x square plus b2x plus c2. Numerator must be linear factor. A is already we have considered here arbitrary constant, so bx plus c plus, now this is repeated for 2 times. First take its first power as the denominator, a3x square plus b3x plus c3, and numerator will be linear factor abc, now dx plus e, and last its second power a3x plus b3x square, b3x plus c3 square of this, and numerator will be next arbitrary constant fx plus g. Okay, in this way you have to express given polynomial in this form, and then only you can find its partial fractions. Okay, all these 4 cases we have considered for proper rational function and quadratic factors in denominator that we are assuming irreducible quadratic factors. Okay, so these are 4 cases to find partial fractions of given rational function. Let us stop here. Thank you all. Thanks.